Okay, hello everyone. My name is Paz, and I will be delivering this session. First of all, I would like you all to know that this session will be recorded and it will be mailed to you. So don't worry about it if you missed a part or maybe if someone will join late. And so the session will be recorded and mailed to you. In addition, you will be muted throughout the session, but feel free to ask questions through the answer them as we go. And in addition, there will also be time for questions at the end. Okay, so the webinar today is about how to bring your Kubernetes and ArgoCD into your internal developer portal. It should be about 45 minutes. Most of it will be live coding. And we're just going to start with a few opening slides to get us acquainted with the topic and what we're going to discuss today. So about me, my name is Paz. I'm a lead architect at Port, and we're a company making the developer portal Port, which we're going to showcase today and showcase its integration with Kubernetes. A little bit about me, I'm a software engineer. I also hosted a CNCF webinar a short while ago about introduction to developer experience. I love video games, bouldering, and burgers. People around the office know that I know all of the best spots in our office's city. And if you want recommendations, feel free to ask me. Okay. And we're going to talk about how internal developer portals can abstract Kubernetes and ArgoCD complexity. And we're going to have a live coding session showing you exactly how Port helps you with that abstraction. And we're going to have a short Q&A section and maybe dive a bit deeper into Port and its capabilities outside of the realm of Kubernetes and Argo. So first of all, let's start with the problem. As most of you probably know, Kubernetes and ArgoCD are pretty complex beings in our infrastructure. They have a lot of objects and they need to be managed properly. And it can be very hard to understand what's going on in our Kubernetes cluster and visualize it properly and abstract away the complexity and show all of the correct components inside our Kubernetes, especially when we're talking about an internal developer portal whose entire goal is to show only the necessary things for our developers to reduce their cognitive load and to make their lives easier. So this is an example of a before state. What you see here is, for example, the view of an application inside ArgoCD. And we can see this graph view, but I assure you that most developers, when they see this graph, they don't really know what's going on. It shows information that is way too in-depth for them to really understand what's happening and how they can react and solve issues that happen in their application and microservices. And our goal with Port and with internal developer portals in general is to abstract away that complexity and giving the platform team a way to auto-discover their Kubernetes cluster and their Kubernetes resources, and also making a mapping from those resources into easily consumable and whitelisted properties and objects that developers have an easy time consuming and interacting with. So if we look at this small diagram, we can see that Port gives you the option to take a lot of exported data from Kubernetes and from ArgoCD, such as the deployment name and the replica count and image tag and all of these other properties that exist on Kubernetes objects, and move those into what we call Port entities. And the Port entity is basically a representation of an asset in your software catalog. So for example, we want the deployment name to go to an entity of a microservice, which is something we're going to see a bit later on when we start the live coding part of this session. And basically what Port gives you is the ability to take all of these properties that exist in Kubernetes and map them to a data model that fits your organization. And we also realize that every organization is a bit different. Every R&D team cares about slightly different things. So we give you the option to model your data exactly to what you want. And from all of these fields and also other fields that you care about, map your software catalog the way you want it. Now, to dive a bit deeper into that example, this is an expanded view of one of our services in one of our clusters. And you can see here how we filled its page with metadata from Kubernetes. So, for example, we took the name and used it as the title for the object. We keep track of the deployment strategy. We can see the current available replicas versus the number of replicas that we want. And all of this information helps us create a map of our Kubernetes cluster, which is tailored for us. And the same way that we do it, every organization that uses Port can do it. And it's very simple. And I'm going to show it when we start the live coding session. One last thing I want to talk about is the components of the internal developer portal. So first of all, our high-level goals for an internal developer portal and for Port is to reduce the cognitive load, which means only showing developers what they actually need, what they actually care about, removing all of the extra information that might confuse them, that they might not require at any given point in time, and make their lives much easier. Promote engineering culture, which is something that we do by using scorecards, for example, which let us say, okay, we want to drive service maturity in our organization. We want to drive higher security practices in our organization. We want to promote better engineering culture and to make sure that our services are up to the highest standards, that they are fault tolerant, that they are secure and can withstand a breach. And the last core pillar that we want to work on is an extensible platform. Port is a builder platform, which means you decide how you want to model data, you decide which information you want to put in the platform, and you decide what you want to expose to your developers. And all of that gives you a very extensible platform, which you can ingest a lot of information into, and then tailor the experience exactly to what your developers need. And now, looking at those pillars, how we achieve them is by these components. So one of them is the software catalog, which is the core part of Port. This is the visibility layer that lets you see all of your microservices, all of your clusters, all of your cloud resources, and understand the connections between them. And we already discussed scorecards when we talked about promoting engineering culture. For example, we can look at our Kubernetes cluster and say, okay, we want to make sure that every service has at least 2 replicas for it to be production ready. And that is something that we can monitor inside the portal and make sure that it actually happens. And we also have our self-service and workflow automations components. Self-service is something that we're going to show in the demo, which basically says, we know that platform teams and DevOps already have their setup backends and scripts, which they use and which they usually deploy for their developers on demand or when they get a Slack message or an email. And we want to save them that trouble and say, okay, the platform team already has that script. Let's just expose it to the developers in a convenient self-service way. And the developer just has to click on the form, input the fields that the platform engineer requested, and click on execute. And things happen in the background, and we saved a bunch of tickets, and we're going to make lives easier and give developers more control and more independence. And of course, all of this is encapsulated in a role-based access control way. So we can very granularly decide which developer sees what in the portal, who can use which action, who has access to which information, to make sure that, first of all, only the correct parties see sensitive information, and also that everyone sees exactly what they need to. They don't see too much extra information to reduce that cognitive load and to make their lives easier. Okay, now it's time for the live coding part. So what we're going to do is we're going to start with a fresh, clean port. And the first thing we're going to do is we're going to use one of our templates. Templates are a way for you to get started quickly inside the world of port. And what we're going to do is we're going to choose the Kubernetes template. So once I click create on that, it's going to create a set of blueprints. I'm going to go ahead and close this for now. What you see here is all of the blueprints that the template created for us. A blueprint is a completely customizable data model, which means every box you see here is a blueprint, and a blueprint has a set of properties. So for example, if you look at the node blueprint, it has the created property, node readiness, the total memory, etc. And every property that you see here is completely customizable and can be configured as you want it. So if I want to just show as an example, I can see here all of the JSON, and say I want to change one of the fields or change one of the names of the fields or their type. I can do that, and I have no limit on the number of properties and their names and their types. I see some people raising hands. If you could please write your questions in the Q&A section, and I'll answer them as I see them. So these are the blueprints that we created for this Kubernetes templates. And as you can see right now, every blueprint receives an empty page because we didn't ingest any data. What I'm going to do now is I'm going to go ahead and deploy our Kubernetes exporter. And the Kubernetes exporter is one of our tools to ingest data automatically. And in this case, it is tailored for Kubernetes. And the exporter can be deployed on your own and completely customizable to your liking. What we did just now is we deployed the exporter from the template, which means it is tailored to this experience and to this set of blueprints. And what I'm also going to do, since I started with a fresh cluster, which doesn't have a lot of information in it, is I'm going to go ahead and add some resources. So I'm going to create some namespaces and create some services and deployments. And now that all of these resources are created, I'm going to go ahead and show you how this looks inside port. So as you can see, we now have our cluster, and we have our nodes and the namespaces that we created, and the workloads, which is, for example, a deployment or a replica set. And we can see the pods of our running services. And another thing we can do is we can go ahead and look at a specific pod and see first of all, we can see its entire metadata and basically every piece of information that we imported from our Kubernetes cluster. So we can see its container definition, we can see its namespace, its labels, etc. And what we also what we can also see is the related entities. Now, the related entities are powered by our relations. As you can see here, our blueprints have lines going from one to another. Each line is a relation. A relation allows us to map a dependency between services and entities inside our blueprints, which gives us the option to actually visualize this relationship across our infrastructure and across our resources, and not only put it in a tabular view, we are also able to get a graphical view of this. So if we're looking at our Kubernetes exported pod, we can see the workload that deployed it. We can see the namespace it's deployed at, and we can see the cluster. And this gives us a really good layer of visibility to really understand how our cluster looks, what are the services deployed in it, and which resources exist in it. And also, we have a complete audit log containing the entire history of every object in our Kubernetes cluster. Now, one extra thing that we can do is, since this view goes across the graph and the relations go across the graph, we can go and look from the other side, look from the cluster side, and see all of the namespaces in our cluster and all of the nodes and all of the workloads and the pods. And if we go to the graph view here, we can see a bit of a different view of the graph, which shows us the cluster and all of the components deployed in it. Now, so far, we've only talked about Kubernetes. So what I'm going to do now is I'm gonna put in some Argo into the mix. So what I'm doing just now is I'm installing ArgoCD on my Kubernetes cluster. And this process will take a few minutes. So in the meantime, what I'm going to do is I'm going to create some extra blueprints that are tailored specifically for Argo. And while we're waiting, I'm also gonna go over them a bit and show you the content of these blueprints. So as I said, a blueprint is completely customizable and it's up to your choice what to include in it. And so in this instance, I'm creating a blueprint for an ArgoCD project. And in this case, this is a pretty lean blueprint. What we do have here is a relation to the namespace, because we want to be able to tie every ArgoCD object to its namespace. And as you can see, we have a new blueprint. And I'm going to create 2 extra blueprints. One is for ArgoCD repo. And another is for ArgoCD app. And now you can see how we extended our map to include some more blueprints, which again relate to the rest of our software catalog and the rest of the mapping that we create for our Kubernetes cluster. Now, the cluster itself should be up by now. So what I'm going to do is I'm going to log into it through my CLI. And another thing we're going to do is we're gonna do some port forwarding so that we can see our web UI for Argo. Okay, let's just make sure that this works properly. There we go. And the port forward should also be on. Let's just verify that. Yeah, and we should have our Argo up and running. Let me just grab the password real quick. Excellent. So right now our ArgoCD is pretty empty because we didn't create any actual applications, but I'm going to do that just now. So there we go. We're going to create some new applications and they should appear in our ArgoCD. Very nice. And what I'm also going to do is, since before we deployed our Kubernetes exporter, the port Kubernetes exporter, when it was only configured for native Kubernetes, what I'm going to do now is I'm going to deploy a new revision that is tailored specifically for ArgoCD, which will help us map some more some more objects that are related to Argo, and actually fill the portal with more information that is specific for Argo. So now our explorer is deployed. And if we go ahead and go to the ArgoCD projects page, we can see the default ArgoCD project. And if we also go to the apps, we can see the new apps that we deployed. And you can see them right here, backend, billing, and front end. And one extra thing I'm going to do is right now, our ArgoCD does not have any repositories. So let's go ahead and add one of those repositories in. And now we're going to see the repository here. And if I go to port to our ArgoCD repositories and hit refresh, and there we go. We have a new repository mapped. And as you can see, this all happens in real time. The Explorer is always running and always listening to events. It will only listen to Kubernetes and other CRD, for example, Argo events, which you tell it to listen to and create a mapping for. And in this instance, we actually listen to all of these events, like a new repo was added, a new ArgoCD app was added, or its state has changed somehow. And we basically listen to all of these things and update the developer portal in real time. Now, after we have all of this information inside our portal, I told you we were going to talk a bit about self-service. So what I want to show you now is how we can use port to expose a self-service action to our developers. So in this case, the action I'm going to show you is updating the replica count of one of our applications. And how I do that is I go to my ArgoCD app blueprint and configure a new action. And actions come in 3 specific types. We have a create action, which is supposed to create a new resource from scratch. We have a day 2 action, which is meant to act over an existing object in our catalog, in our cloud infrastructure, in our cluster. And we have a delete action, which is meant to delete an existing resource. And actions are configured very similarly to blueprints. And they also include a list of properties. And these properties are translated to a nice UI form that our developers can consume when they want to use that action. So I'm going to go ahead and save that. And now when I go to ArgoCD app, let's say I want to change the number of replicas in my front end because it is underperforming, we need more endpoints, or whatever the case may be. So let's go ahead and choose 5 as the replica count and specify my service. Now, just to verify, at the moment, we only have 2 replicas. Now, what I'm going to do is I'm going to hit execute. And imagine at this point that I am a developer, same as any other developer in my R&D organization. I see that my app is malfunctioning, maybe not performing as well as it should. And I decided that the best course of action is to update the replica count. So I'm going to go ahead and hit execute. And the action drawer actually shows me the new action that I triggered. Now, in this specific instance, the action that we triggered triggers a GitHub workflow. So if I click on the job link, I can actually see the triggered workflow, and I can see that it started just now. It's going to update the replicas. And now I can see that it's complete. And I can also see inside my portal that the job has changed to successful. And I can also always go back and see the inputs that I inputted in. I can also see who triggered the action and when and on which entity, which in this case was the ArgoCD front-end app. And now ArgoCD should have a small syncing process. But if I force it to sync, then I should see that the replica count has updated. So let's just verify that that is exactly what's happening. Let's do a quick sync. And there we go. We can see a bunch of replica counts. And I'm guessing that some of these are draining because we increased them by so much, but we can see that a few of them started just now, which means this is the result of our action. And basically we can see that the developer had a chance to immediately make an update. And this shows you exactly how developers can use self-service actions and use the portal in a self-service manner to consume certain actions that usually they would have to get the platform engineer or the DevOps engineer to perform for them, maybe because they don't have the knowledge or they don't have the right permissions or the right tooling to perform them. Now I see Robert has a question, and Robert asks, in your action, you had to select the app, even though you started the action from an app. Can that info be passed automatically? Yes, it can be passed automatically. In this instance, I decided to also manually transfer it to make my GitHub action a bit simpler. But it is 100% possible to query it directly from the object that gets sent. And I will actually go ahead and show you a bit of the documentation about actions to show you exactly how that payload that gets sent looks. So if I go to our, and first of all, our documentation already includes a lot of information, and a lot of the things that I've shown here are very well documented. In addition to having the templates inside Port, if you go ahead right now and start a new instance of Port, you just sign up. It's completely self-serve. So you can go ahead and sign up and get started with the templates and just get started right away with what I've shown you about Kubernetes, and install the Explorer on your Kubernetes. Then you will immediately see all of the information from your Kubernetes cluster. And of course, you're not limited to just one cluster. You can map as many clusters as you want and as many clusters as you have, and really tailor the information that you see. So following up on Robert's question, this is an example of the payload sent for a create action. And what you see here is that the entity is null, but since, remember that the action that we triggered was a day 2 action. So in that instance, the entity here will not be null, and we can use it in our action. I just changed the steps a bit so that my GitHub workflow would be a bit simpler and a bit shorter. Now, if we go ahead and dive again back into the results. So first of all, we can see here in front end, we can see an action run relating to our front end where we changed the replica count. And as we've shown before, we have a complete map of our cluster and our apps. So if I go to the graph view and I look at our app, so we can see front end here, and it's part of the front end workload, and it's in the default ArgoCD object in the front end namespace. And it's part of our webinar cluster, which we just created. And remember that we started all of this maybe 20 minutes ago, and we already have an excellent layer of visibility to our Kubernetes. And again, if we go and watch the graphical view of our cluster, then we can see an entire map, and we can see that our cluster is pretty sprawling at this point. But all of this information is inside the portal. It gets updated in real time. It is very easily digestible. So for example, if I want to extract some information, maybe I don't want to see all of the pods, and maybe I don't want to see all of the repos, then I can really get a nice graphical view of my cluster and of its namespaces, for example. Now, one small thing that I wanted to show you is our scorecards, which should be in this template. There we are. So if we go ahead and look at our node, we configured some scorecards on our nodes blueprint. And these are mostly related to production readiness. And of course, a scorecard is a set of parameters that you configure, that you choose. What are the metrics that you care about, and you choose how to categorize them and how to group them inside levels to say, okay, my Kubernetes nodes must have a Kubernetes kubelet version of at least 1.2, and that is the bronze tier, meaning that is the minimum requirement I have for a Kubernetes node in my environment to be production ready. We can go ahead and say, okay, in order to actually be prepared for production, I want it to be something a bit newer. I want it to be a bit closer to the active Kubernetes track. And if we go ahead and look, for example, at one of our workloads and look at its scorecards, then we can see that, for example, in here, we are only at the bronze tier. And why is that? Because we configured the high availability tier or category and said, okay, we want the number of wanted replicas to be at least 1, but if we want to go to silver, it needs to be at least 2. And if we want to be gold and we want an actual live and production ready and highly available application served from our Kubernetes, then we want the number of wanted replicas to be at least 3. So this is, again, another example of how you can use the information that you ingest into port and into your developer portal to drive that engineering excellence and to drive certain initiatives such as high availability, high security standards, a high level of production readiness. Okay, that would close our live coding session. And now we have some time for a Q&A. So feel free to type questions in the Q&A, and I will answer them as we go. So I see a question from Jose. I hope I'm pronouncing your name right. And he asks, by using port, is there a way to go for a multi-tenancy? That is, by using permissions or profiles, a set of users would only have visibility or permissions on a certain set of Kubernetes namespaces or Kubernetes resources. And the answer is yes. As part of port, we offer a very strong layer of role-based access control. And what this layer will give you is the exact option to say, okay, I only want developers from this team to see this specific namespace, which includes the microservices that they are responsible for and that they are maintaining and deploying. And you can make sure that only they have the option to see those namespaces and microservices, and other teams do not have those permissions. And you have complete control. You can say, okay, I want the platform team to see everything, and I want specific development teams to see only specific parts. So just to show you a bit how our permissions model looks, permissions are configured over a blueprint, same as most resources. And it's basically a JSON object showing you exactly who can create new entities, who can update entities, who can delete entities in a level of granularity that fits for you. For example, you can do it by role, by user, by team. You can also assign permissions based on team ownership, saying a specific team owns this namespace, which means they have complete control over creating, editing, or deleting entities from that namespace blueprint. So I hope that answers your question. Robert asks, is there a self-hosted version of Port available? We are currently a SaaS offering, but we are working on a self-hosted offering. And I do not have an exact date to share about it right now, but we are working on it and it will be available soon. Juan asks, do you have a template for those that are using Elastic Beanstalk? So in addition to our Kubernetes exporter, we also offer an AWS exporter, which has a complete documentation in our docs. Oops, sorry, let me just show it. So basically, our AWS exporter allows you to extract information from your AWS account using a simple Lambda function. Basically, we give you a CloudFormation app, which you deploy in your AWS account. You configure it quite similarly to how you would configure the Kubernetes exporter. And then it brings over data from AWS in real time and based on events. So for example, if something happens to your Elastic Beanstalk, something happens to one of your Lambdas, you deploy a new ECS service or anything like that, you get that information inside port in real time. And in a very short while, we are also about to offer, similar to how we offer a Kubernetes template, we'll also offer an AWS template. So for example, if I click on get this template, it will also create the required blueprints. And it will also actually show you how to deploy our AWS exporter on your AWS and begin extracting data. And if I go ahead and look at the results of the creation, so I can see I got a new blueprint for ECS, App Runner, for an AWS region, for an AWS Lambda. And basically every object that exists in AWS can be imported by using the exporter. And you just need to install it and configure the target blueprint that you want to map those AWS objects to. And we have an anonymous viewer asking what happens behind the scenes when you increase the amount of replicas and send a command to Kubernetes or change your Helm chart in the repo. So since this use case is using ArgoCD, and we have an ArgoCD app, which is mapped from a config file, which sits inside a Git repo, what the action does is it goes ahead, it checks out the repo, edits the target configuration that we asked. So in our example, we ran the change replica set action on our front end app. So it went ahead and took that YAML and edited the number of wanted replicas. And then we checked it into the repository. And after a while, ArgoCD syncs it back. And we have the changes deployed. So we have the new number of pods and wanted replicas for our ArgoCD app. Okay, so I can see that we have no more questions. I appreciate you guys joining the session today. As I said before, the session is recorded and will be sent to you. So no worries if you missed a part or you joined in the middle or anything like that. You will have the complete session and you can play it back as much as you want. As I said before, port is completely self-serve. You can go ahead and use app.getport.io to get started. If you want to get inspired and see where port can go when you continue building into it and start modeling your perfect developer portal inside it, you can head to demo.getport.io. I hope this session was helpful. And hopefully you will join us for some future sessions. Thank you all very much.